Alright, so this is the section 7.3 lesson video for honors chemistry. And so in the first couple of sections of chapter 7 we were talking about ionic bonding, and so now we're going to focus just for a little bit on metallic bonding, or bonding in metals. So the valence electrons of metal atoms can be modeled as a sea of electrons. So they can kind of flow around to different metal nuclei. So metallic bonds consist of the attraction of the free-floating valence electrons for the positively charged metal ions. Metals are good conductors and malleable because of their mobile electrons. So in normal substances, an electron stays with that certain nucleus that it belongs to. Like it might be lost or gained in bonding, but once that happens, it stays with that nucleus for the majority of the time. Sometimes we'll talk about sharing and things like that. But in metals, their valence electrons can kind of move around and be attracted to any of the positive metal ions. So it's called the sea of electrons because they can kind of flow over here, they can flow over there, and that's what allows it to conduct electricity, because electricity is the flow of charge or electrons. And so since the electrons are allowed to move, that's why they're good conductors. So metals are the most simple crystals because they only contain one type of element or one type of atom. So metals are crystals. Again, just because you don't think of it as a crystal just has a 3D repeating pattern. And so metals are very orderly in their solid forms. So they are crystals. An alloy is a mixture with metallic properties. So there's two main types of alloys. There's substitutional and interstitial. So a substitutional alloy is made up when atoms of one metal replace atoms of another metal. And so what it's going to look like is this. Like here we have some copper and we have some zinc. Of course, this is literally pointing at the zinc. It should be pointing to kind of the tannish atoms. And so this is a substitutional alloy. This happens when the atoms are of similar size or radius. The other type is an interstitial alloy. So here we have some iron atoms and some carbon atoms. And so if you look, we have small atoms inserted in between the larger atoms. That's what's happening in this example. Okay, so let me just draw a picture of it because these pictures aren't very good that I found online. So you have smaller metal atoms that kind of insert themselves in between the larger metal atoms. And so this type of alloy would occur if there is a large difference in the size of the atom or the radius. So if they're of similar size, they tend to make a substitutional. If they are of different sizes, the smaller ones tend to insert themselves in between the larger ones. And then the reason that we make alloys is just to enhance properties we like and to kind of try to stop the properties we don't like. So we might make an alloy to make a metal stronger, or maybe to make it lighter for aircrafts, or to make it less likely to rust. So we try to increase the positive properties and decrease the negative properties. That's why we make alloys. So, boy, that section was fast, section assessment. That's good that it's fast after those two longer videos I just made. So how do chemists model the valence electrons in metal atoms? Well, remember, it's modeled like a sea of electrons. And so remember, that just means those valence electrons are mobile. They can move around. How can you describe the arrangement of atoms in metals? Well, it is a crystal, so it's a 3D structure. Or we can say a crystal, or you could say orderly. There's lots of ways that you can describe the arrangement of atoms in metals. Why are alloys more useful than pure metals? Well, remember, like I said, alloys are made to enhance positive properties and to kind of get rid of negative properties. So they are made to enhance positive qualities. So like I said, if something needs to be lighter, like weigh less, you could make an aluminum alloy. Aluminum is a light metal. If something rusts easily, maybe use a stainless steel type alloy to help, combat the rusting, things like that. Steel is made by adding carbon to iron because it enhances the strength of it. So then number 4, describe what is meant by ductile and malleable. Well, both of these are used to describe metals, Ductile specifically means can be pulled into wires. And malleable means can be hammered into sheets. So both of them, although those are the official definitions, both of them mean that metals can be reshaped. They're not brittle and necessarily just break if you try to bend them or reshape them. All right, so that's what we need to know about metallic bonding. You need to know about those sea of electrons, and like I said, make sure you know the difference in interstitial and substitutional alloys.